Today we're going to focus on trigonometry and trigonometric functions. Let's start by going through some broad overview of a couple of the main points and topics in trigonometry. The first being the conversion between radians and degrees. So 1 radian is 180 over pi degrees, which means that 1 degree is equal to pi over 180 radians. And just remember that when we are calculating an angle or the trigonometric value at a certain angle, that angle can be measured in radians or degrees. It's going to depend on the problem, and this is the conversion between those two units. So, unit circle. If I have a circle on a coordinate plane, and the radius of that circle is 1, I can break up this coordinate point here into a y value and an x value. And we also have this angle theta. So this is x comma y. Trig functions are defined as the relationship between this angle, theta, and the x and y values. So, for example, if I have sine of theta, that is equal to the y value of our coordinate point. Similarly, cosine of theta is equal to the x value of our coordinate point. Okay? And then the third one we talked about of the three basic trig functions is tangent. Tangent of theta is defined as the ratio of sine over cosine. So in this case, this will be y over x. So those are the three basic trig functions. We also talked about the inverse trig functions. So the inverse of sine is a cosecant. So cosecant and so this can be calculated. So cosecant of theta, it's really 1 over sine, but we can just write 1 over the y value. The inverse of cosine is secant, so secant of theta, and that is 1 over the x value, because x is defined as cosine of theta. And then lastly, cotangent of theta is equal to 1 over tangent. We can do 1 over y over x. That just becomes the reciprocal of x over y. And those are the 6 trig functions that we talked about in this unit. And then lastly, before we get started on some problems, let's just cover transformations of trig functions. So if I have a basic trig function here where we've transformed this trig function accordingly, let's discuss and determine what each of these letters do to the shape and the behavior of the graph. So number 1, the letter A will vertically stretch sine, in this case, by A. The B indicates the horizontal stretch, so this is a horizontal stretch. By 1 over B. h is a horizontal shift, so h, and then the k gives us the vertical shift. Okay, and then lastly, these letters also give us some of the key characteristics. There's 3 key characteristics of the graph of a trig function. The first key characteristic is the midline. That is defined as the k value. It's a horizontal line, so we're going to write y equals. So y equals k. That's our midline. The amplitude is the distance between the midline and either the peak or like the valley of our trig function, and that is defined as the absolute value of a. So whatever the magnitude of a is, that's what we're going to use for the amplitude. And then the trickiest one here is the period. The period is defined as 2 pi over whatever the b value is. And that gives us the distance of one repeating cycle of a trig function. Okay, so let's start by going through evaluating trig expressions, and then we're going to get into analyzing and graphing some of these trig functions. Here we have 4 different trig expressions, and we're going to use a few of those notes that we just talked about to evaluate the exact numerical value of each of these trig expressions. So let's start with the first one here. If I have sine of 17 pi over 4, the first thing we want to recognize is that this is a radian measurement, and what we want to do is locate where this would be on the unit circle. Well, the tricky part about this one is this radian measurement is beyond 1 rotation around the circle. So we have to kind of figure out how many rotations we've gone through and then kind of what's left over. Well, 1 rotation is 2 pi radians. And so what we can do is break this down into 16 pi over 4 plus pi over 4. And the reason why we're doing this is because this is equal to 4 pi. And that represents 2 rotations. Around the unit circle. Okay, so let's graph this. So what we're going to do is we're going to go 2 laps around, and then what we're left with is pi over 4. So 17 pi over 4 is located here on the unit circle. And so what we do here is we go start here. This is 2 pi. This is 4 pi, or 16 pi over 4. And then this last kind of spot right here is pi over 4. So this entire rotation sequence is 17 pi over 4. And so we're located here. And so we would say the reference angle, which is this angle right here, this is pi over 4. Okay, because we are at pi over 4 from the starting point, we know that the coordinate point here is going to be root 2 over 2, comma root 2 over 2. And so sine of 17 pi over 4 is equal to root 2 over 2, because sine represents the y value of our coordinate point. Okay, let's do this again with tangent of negative 2 pi. All right, this one is a little bit easier because we're not going to be dealing with any of those special right triangles. We're just going to be using a point that's on one of the axes. So if we're dealing with negative 2 pi, we're going to be going clockwise, and 2 pi is one rotation, so this is negative 2 pi. And so the coordinate point is going to be located here at 1, 0. Well, tangent is defined as y over x, and so this is 0 over 1. And so tangent of negative 2 pi is equal to 0, which is the ratio of 0 over 1. So that's our answer for the second one. All right, number 3, or letter C, I should say. That's number 3. Cotangent of negative 240 degrees. So this one's in degrees, which is a little bit nicer, I think, especially if you're less than one rotation around the unit circle. So negative 240 means that we're going to be going clockwise. So we start here. Let me redraw that. From this point to this point, that is 180 degrees. And then what we're going to do is go an additional 60. And so this reference angle here will be 60. And this is going to be negative 240 degrees. So we go 180, which is halfway around the circle. And then we go an additional 60. So this is 60 degrees. Okay, and the reference angle is important because it'll give us the key to finding the values of the coordinate point using the special right triangles. So think what is the length of a triangle whose opposite side is 60 and the hypotenuse is 1? Well, that's going to be root 3 over 2, and that's the y value of our coordinate point. The x value is going to be negative because we're going to the left of the y-axis, 1/2. And so cotangent of negative 240 degrees is equal to x over y, which is equal to, in this case, negative 1/2 over positive root 3 over 2. The 2's will cancel, and we're left with negative 1 over root 3. We can rationalize the denominator here, and to do that, we just multiply by root 3 over root 3. And so what we'd say here is cotangent of negative 240 degrees is equal to negative root 3 over positive 3. And that's the answer for the value of cotangent, negative 240. Okay, and let's wrap up this first problem set by going through secant of pi over 2. All right, this one's nice because we should know where pi over 2 is located on the unit circle. So pi over 2 is here. It's this. Secant is 1 over cosine, which is 1 over x. And so secant pi over 2, in this case, is equal to 1 over 0, the x value of our coordinate point. 1 over 0 is undefined, and so that's the answer for this one. We said that the value of this trig expression is undefined. It does not have a number. Sorry, this should be number 4. Okay, let's wrap this up by going through some questions involving a graphical approach to these concepts. And let's wrap up this video by going through 2 questions involving graphs of trig functions. The first one, we're going to go from an equation to a graph, and then the second question, we're going to go through from the graph to the equation. So here we have the equation of a specific trig function. And our goal here is to graph this on this coordinate plane here. So in order to graph these, what we want to do is identify the three key characteristics that we talked about at the beginning of the video. The first being the midline. That is going to be the k value, which is the number on the outside. So in this case, the k value is -1. The second key characteristic is the amplitude. I'll color code these, why not? -1. The amplitude is defined as the absolute value of A, which is the absolute value of 3. So in this case, the amplitude is 3. And what that means is the function will not go below the midline minus the amplitude, so it won't go below -4. And it won't go above the midline plus the amplitude, so it won't go above 2. Lastly, we're going to determine what the period of this is. The period is defined as 2 pi over the b value. Well, the b value is 2, so it's going to be 2 pi over 2, this number right here, and that's going to be pi. So that's the length of one repeating cycle of this trig function. And then lastly, what we want to do is recognize that we're dealing with a sine function. And so the sine function is going to start at the intersection of the y-axis and the midline, given that there's no horizontal shift. And what that means is it's going to start here. And then it will return back to the same position after pi units to the right or the left. Okay, so let's draw this. It's going to start here. It's going to reach a maximum, return back down, reach a minimum, and return to its original location, undergoing one cycle over the course of pi, a distance of pi. So it's going to go up, come back down, go down, come back up. So that's one cycle. So let's do it again. Goes up, comes down, comes back up. That one's not as good. And it will continue going like that. Now let's do the same thing to the left. So it goes down in this case, comes back up like that, and then goes down, comes back up, comes down again. So that's the idea. Not a perfect graph, but as long as those key characteristics are identified, that's what I'm looking for. Now let's go from the graph to the equation. So here we have the graph. Let's identify those three characteristics first, and then let's try to make an equation from those characteristics. Let's start with the midline. So at the midline, we're just going to look at the graph. It looks to be y equals 1. That's kind of where the function's centered about. If the midline is 1, then the amplitude is the distance from the midline to either the top or the bottom of the graph. And so the distance between 1 and 4 is 3. Sorry, this is 1, not -1. And the distance between 1 and -2 is also 3. So that means the amplitude for this one is 3. The amplitude is 3, which means the A value is 3 in this case. And you will see it's going to be a positive 3. And lastly, we want to find the period. So the period is 2 pi over the B value. The B value in this case is what we're going to look for, so B. And we're going to basically look at the graph to identify the period and then identify the b value from this equation here. So the period is the length of one cycle. And so if we start here, the length for it to return to its original location and undergo one cycle, in this case, is 4 pi. So we're setting the period equal to 4 pi. Okay. And what we're going to do now is we're going to solve this for b. Once we solve this for b, we'll have everything we need to make the equation of our graph. So I'm going to multiply by b on both sides and then divide by 4 pi. So b is equal to 2 pi over 4 pi, which is 1/2. Okay, so notice we're starting at the intersection of the midline and the y-axis. So we're going to be using a sine function, and it goes up, so it's a positive sign. So, and it also appears to be no horizontal shift, which is nice because there's going to be no h value. So the answer for this is going to be 3 sine of 1/2 sine of 1/2 times x plus 1. And that is the answer for this question. That's the equation of this graph over here for number 2. Okay, with that, let's wrap up the lesson for today by going through the additional practice here. On the OneNote, the answer key for this question is located down below. So once you finish the video, let's work through this problem set here.